Today's lesson is on scatter plots and lines of best fit. First, we'll look at our key idea for a scatter plot. A scatter plot is a graph that shows the relationship between two data sets. The two sets of data are graphed as ordered pairs in a coordinate plane. For our first example, we're interpreting a scatter plot. The scatter plot at the left shows the amounts of fat in grams and the numbers of calories in 12 restaurant sandwiches. For A, how many calories are in the sandwich that contains 17 grams of fat? So if you look at our scatter plot on the left, we're going to find the number 17 at the bottom because that stands for fat in grams, and that would be in between 15 and 20. Then we're going to go up on our graph until we see our dot. We'll then go to the left to find out what number that matches up with, and that is 400. You can see the example on the right shows you this information. So we started at 17, we went up to the dot, and then as we go over, we see 400. So the sandwich has 400 calories. For B, how many grams of fat are in a sandwich that contains 600 calories? So looking at the scatter plot on the left, we can go up to 600 on the left-hand side because that stands for calories. Then we're going to go across until we hit a dot. We hit a dot right here. Now we're going to go straight down and see that it is 30. So the sandwich has 30 grams of fat. You can see that it has been done for you at the scatter plot on the right. Start at 600, go over till you find a dot, and then you can come down to find out what matches up with that dot, which was 30. C, what tends to happen to the number of calories as the number of grams of fat increases? If you look at the graph, the plotted points go up from left to right. So our plotted points from left to right are going up. So as the number of grams of fat increases, the number of calories increases. So as you have more fat, the number of calories is getting larger as well. Now we're going to look at different scatter plots. A scatter plot can show that a relationship exists between two data sets. For our first scatter plot, we're looking at positive linear relationship. The points lie close to a line, so they look like you could draw a line through them. As x increases, y increases. So as x is getting larger, y is also getting larger. That would be positive linear relationship. For the second one, we're looking at a negative linear relationship. The points lie close to a line. So you can see we could basically kind of draw a line in between those. As x increases, so as x is getting bigger, y is decreasing. So y is getting smaller. And this would be a negative linear relationship. The third one is a non-linear relationship. The points lie in the shape of a curve. So you can see that we wouldn't have just a line that goes through them. It looks more like a curve. That would be a non-linear relationship. And for the last one, there is no relationship. The points show no pattern. We can't draw a line that would go through them. Okay, can't draw a line. There's not a curve that will go through them. So this one has no relationship. For our second example, we're identifying relationships. Describe the relationship between the data. Identify any outliers, gaps, or clusters. So for A, we're looking at television size and price. So you can see that we have along the bottom the television size, and along the side we have our price in dollars. The points appear to lie close to a line. We could take a line and we could draw them through the points. It wouldn't hit every point, but it would be a representation of the data. As x increases, y increases. So as our numbers for x are getting larger, our numbers for y are also getting larger. So the scatter plot shows a positive linear relationship. There is an outlier at 70, 2,250. So that would be here 70 and then 2,250. This right here would be our outlier. If we drew a line, that one would not remain close to that line. All the rest of them are pretty close to the line, and this one stands out. A cluster of data under $500 So you can see our clusters right here, that would be under $500, and a gap in the data from $500 to $1,500. So here is our gap. There's nothing in this space. For B, we're looking at the relationship between age and number of pets owned. The points show no pattern. If you look at this data, you can't just draw a line through the data. You can't draw a line. There's no curve that you could draw through the data. They have no pattern. The dots don't form anything. So the scatter plot shows no relationship. There are no obvious outliers, gaps, or clusters in the data. Now we're going to look at our vocabulary. A line of best fit is a line drawn on a scatter plot that is close to most of the data points. It can be used to estimate data on a graph. For our third example, we're finding a line of best fit. The table shows the weekly sales of a DVD and the number of weeks since its release. A, make a scatter plot of the data. B, draw a line of best fit. C, write an equation of the line of best fit. D, predict the sales in week 9. So first we'll start with A, make a scatter plot of the data. So here is our data. We're going to transfer this data over to our graph. So X would be 1, Y would be 19. So we would go over to 1 and up to 19. Our next point would be 2, 15. So over to 2, up to 15. Then we have 3, 13. So over to 3, up to 13. 4, 11. So 4, 11. 5, 10. 6, 8. 7, 7. And 8, 5. So first we plot our data. The scatter plot shows a negative relationship because as X is increasing, Y is decreasing. Now our second part, draw a line of best fit. So you can see that the line was drawn around these points. It's not going to touch all the points, but it should be in between the points. So you might have some on the line, you might have some to the left of the line and some to the right of the line. Try to have as many points above the line as below it. So you kind of have about an even amount of points. So here we have 1, 2, 3 above and 1, 2, 3 below. And then we had 2 that were right on that line. Now for C. For C, we're going to write an equation of the line of best fit. So now we're going to try to write an equation with the line that we just drew. The line passes through 5, 10, and 6, 8. So we can use those points to find the slope. If you remember, the slope is rise over run. So if we look here, when we're going to go up, so our rise, we're starting at 8, going up to 10, and then our run, we're going from 6 over to 5. So you're going to have negative 2 over 1, or you could have said 2 over negative 1, but that would still be equal to negative 2. So our slope is negative 2. Because the line crosses the y-axis at 0, 20, so you can see up here it's at 0, 20, the y-intercept is 20. So the equation of the line of best fit is y equals negative 2x plus 20. Negative 2 was our slope, and 20 was our y-intercept. To predict the sales for week 9, so for D we want to predict the sales of week 9, we substitute 9 for x in the equation of the line of best fit. So we can take 9 and substitute it in our equation. So we have y equals negative 2x plus 20. We're going to substitute 9 in for x, so we'll have negative 2 times 9, and then plus 20, and negative 2 times 9 is negative 18, plus 20 is 2. So the sales in week 9 should be about 2 million. So now we can see if that works on the graph that we have. So week 9, we can go up here, and then we can go across and see that it does match up with 2. If we look at our study tip, it tells us a line of best fit does not need to pass through any of the data points. Sometimes it will. In this case, it has through a couple of them, pass through 2, but it doesn't have to pass through any of them. But you should have some on both sides, above and below your line.